In this lesson, we are going to solve this question I have on the screen. The question says determine velocity of pendulum bob at A2. Okay, if it is released from rest at what A1. The length of the string A0 is given to be what 0.8 meters. So let's look at how you are going to solve this question. Okay, so we've been told that the bob was at rest at what position A1 over here, and then it was released to what position A2. So let's find the velocity of the pendulum bob at what position A2. To do this, we are going to apply the principle of conservation of what energy, and that is stated mathematically over here. Okay, so that's the sum of the initial energies equals what the sum of the final energies plus what energy lost due to what friction. So this is what the principle of what conservation of what energy says. By looking at this system here, we don't have any elastic element in it. So the potential elastic energy will be equal to what? Zero. Okay, so this value on the left hand side will be zero, and then same as that on the right hand side. And then this system here is considered to be a conservative system, which means that there is no energy lost due to what friction. So in that case, energy loss will be equal to what? Zero. So when you look at the second line over here, I have 0 over here and then 0 over here, and also I have what 0 here also. So that's what that means. Okay, so now at the end you see that what mechanical energy is what conserved. Okay, so you have the some of the initial kinetic and then potential energy to be equal to what the sum of the final kinetic and then potential energy. So now let's focus on this. So I'm going to consider the ball at position A1. Okay, so let's look at this here. So at position A1, the initial velocity is given to be 0 meters per second since the pendulum bob was at rest. Okay, so the initial velocity will be 0. And then looking at the height, okay, looking at the height, when I consider position A2 as my reference position, and then I measure the distance from the position to point A1, that gives me the height. Okay, and this height here will be the same as what the length of the string. So you are going to have L to be equal to what? H. Okay, you're going to have the length of the string since the string is not what elastic. So the height H will be the same as what the length of what of the string. Okay, so now we know that what the length of the string is what 0.8 meters. So that means that at position 1, the height will also be what 0.8 meters. Okay, so now let's do same for the bulb at what position A2. So at position A2, so at position A2 ought to be the velocity. So at position A2, the pendulum will still continue to be in motion. So velocity there will not be what? Zero. Okay, velocity there will not be zero. So that's the velocity you have to find. So we don't know this velocity yet. And then at position A2, since you are considering A2 to be the reference line, then the height there will be equal to what? Zero, because that's where we are starting the reading from. So now we know these two values here for the pendulum bob at what position A1 and then position A2. So let's substitute this into this equation that we have here. Okay, so let's do this. So on the left hand side, I'm going to have half mu squared. Okay, so mu, and then we know u to be at 0, so 0 squared plus mgh1. Okay, h1 is what 0.8, so I will have 0.8 here. So this will be equal to what? Half mv squared, okay, plus mgh2, which is what? 0. Okay, so this is what we have now. So all you have to do is to simplify this. So on this side, you're going to have 0 plus 0.8 multiplying what? Acceleration due to gravity, which is what? 9.81. Okay, then the mass will come. So this will be equal to what? We will have 0 here. Okay, we're going to have 0 here. So that will be 0.5 mv squared. Okay, I wrote the half as of 0.5. So at this point, you can see that we can cancel out the mass. Okay, so this mass will cancel out this mass here. Okay, so and then we are going to have 0.8 multiplied with 9.81. So 0.8 0.8 times 9.81, that give me a value of 7.848. Then that will equal to 0.5 v squared. So I'm going to divide both sides by 0.5, both sides by 0.05. So this will cancel out this. So 7.848 divided by 0.5. So that gives me a value of 15.696. So I'm going to have, let me write this here, v squared. So continue from this, I'm going to have what v squared to be equal to 15.696. Okay, so we want to find v here. Okay, so you have to take square root of what you have on the right hand side. Okay, so let's go ahead and then do this. So I'm going to have v to be equal to the square root of 15.696. Okay, let's see the value of this. So this will give me a value of 3.962 meters per second. Okay, and then I can approximate this to 4 meters per second. So this will be the velocity of the pendulum bulb at what position A2. Thank you very much for watching this video.